Hello, brothers and their sisters. Today we are going to start a new course known as multi-body simulation, which is nothing but the robotics concept in a Matlab. So we are going to try it on a Matlab online, which is nothing but a simulating online. So let's start the course. Until now, I have completed various courses. I can show you. So as you can see here, I have completed this all courses. These are basics to understand what is meant by a system or what a system really is. So to understand this type of stuff, you have to go to the MATLAB courses, and you have to uh, learn about them. So now what we have to do here, multi-body simulation, familiarize yourself with the course overview. So we will start with the course overview.
Hello,
Let's start.
and welcome to Multi-Body Simulation OnRamp. This course will introduce you to modeling and simulating 3D mechanical systems using Simscape Multibody.
Which is nothing but the freedom of degree in robotics.
In our rapidly transforming world, driven by electrification and automation, understanding the dynamics of systems with multiple moving parts.
So basically it is same concept as I told you, that from this courses we can understand what does really a system do or what is meant by system. So to understand the dynamic of a system, we have to learn about the system. For that, Matlab courses are perfect because it is free and it clear the mindset of an individual or a student who needs to be focused to the robotics
Has become more crucial than ever.
or a system.
These systems are everywhere, like drones executing complex flying patterns or rovers.
So basically, when I have done the PID controlled, which is nothing but a control system program in a Simulink, so I understand that drone is not just about motors and ESCs, which controls the whole motions or the position of the body, but it is also a systematic, or you can say a high level mathematics calculation which integrates with the integration probability and the differentiation. So it is nothing, modeling is nothing but a pure mathematical concepts. Okay.
Exploring uncharted terrains on alien soils, and even heavy construction equipment tirelessly shaping cities. Our world is indeed a dynamic stage teeming with increasingly sophisticated machinery. But how do engineers make sense of the intricate movements of these complex
By
machines?
mathematics.
This is where Simscape Multibody comes in. With this powerful tool, you can model and simulate almost any mechanical system you can imagine. Think of Simscape Multibody as a virtual lab.
Just think about it. You are sitting on a earth, you are programming or you are developing a model on a PC, and you can calculate that what will be the system do if it is on the moon surface or the Venus surface. Oh, sorry, not Venus surface, Mars surface. So it is fascinating, and these fascinations can also lead towards learning.
Where you can experiment safely and gain valuable insights through simulations. For instance, picture yourself designing a forklift in Simscape Multibody. You can test how fast it can move, how much weight it can lift, and even assess the risk of it toppling over, all without investing time and money in physical prototypes.
Yes.
Simscape
That's why the
Multibody
simulations are the main tool, or you can say key, for the engineers who wants to be a designer, or you can say a high level engineering uh, tool. So basically, what is engineering? Engineering is nothing but a research and development part, where the researchers are completely different type of peoples who first make some research, make some discoveries, and based on that research and discovery, an engineer will calculate and make the proper system budgeting or the power budgeting or the system architectures. Then that data will taken to the next engineer, which will do the mid-level engineering, means building a prototype, doing some debuggings, in codes, error, doing codes, doing debugging, and after that, when the code and the hardware prototype is completely ready, then that part will go towards the low level engineer, which will just manufacture the product. So basically, you can say that engineer will make the architecture, will make the system analysis, will do the system analysis. The low level engineer is nothing but a labor or manufacturer which will manufacture the product, and the mid level engineer will take the data from high level engineer and convert that data into a prototype based on which the manufacturer will done.
Empowers you to run these multi-body simulations, providing a cost-effective way to anticipate
See,
and
it
prevent
is pure
accidents,
mathematics.
fine-tune system performance, and boost equipment safety and reliability. In this course, you'll learn how to piece together 3D bodies into articulated mechanical systems. These models come to life in the Mechanics Explorer app, where you can visually explore your multi-body creations. Additionally, you'll get hands-on experience with actuating your system using forces and torques, prescribing joint
Just
motion.
think about it that you are using a ESP, or you can say other microcontrollers, and you are connecting that ESP to a phone which is connected to a cloud server and a proper website. A website will contain the proper ML model which can read your hand movement, and based on that hand movement, the model inside your computer will move. Just think how much fascinating is it. Or you can also think about it like you are building a proper satellite without needing any type of external components, just a proper mathematics and a simulation. Oof, it is too much fascinating for me, and I am having a goosebump just thinking about it.
Motions and modeling contact forces between bodies. And in the final project of this course, you'll model and assemble a robot arm capable of sketching a variety of technical drawings.
So this is the basic model, and I will tell you one story that where I have visited the RTMNU Expo this year. The college student have make this line sketching robot, and now if I am learning something new and my basic project will be that project, then it will make me more sorry, it will boost my confidence, I guess. Okay, so let's start with course and we'll chat less. Okay.
Based on a blueprint. To make the most out of this course, you should have a basic understanding of mechanical systems and
So first of all, what I know about the fluids, I know about the electricals. I don't know about batteries and driven lines. So is there any course related to this? If yes, then I have to say it. Let's see. Organize tabular data in Matlab. No, I don't think that there is any type of course related to this. Okay, but here you can see there are options. So modeling, simulations, programming using Simulink. All Simulink, get started with Simulink, modeling and simulation, physical modeling. Okay, so in physical modeling we can go to power electronics, circuit simulations, motor modeling, battery. Yes, so I need to understand this first, I guess. So what will I do? I will go towards the multi-body simulation onramp, and I will see the recommended course I have to do here, Simscape. So obviously I have completed the Simscape, so I don't think that I need to understand the basic
modeling physical systems in
drive
Simscape.
lines and battery and electricals.
If you need to refresh your knowledge of Simscape,
Okay, power system and circuit simulation are necessary.
consider taking Simscape OnRamp first to gear up for the journey ahead. So, are you ready to explore the fascinating world of multi-body
Yes.
simulation?
Yes.
Enjoy the course.
You can see the moving objects which are moving because of maths is the next level dopamine for me. It's like addiction. Model a mechanical oscillator. So welcome to a multi-body simulation on RAM. This could teach you how to model and visualize 3D mechanical system using Simscape multi-body. Now In the first activity, you will simulate the visualization and dynamics of a mechanical oscillator in a Simscape multibody. Okay, press next. This is a new course for me, and I'm very much excited for this type of course because I like the proper mechanics and electronics. And when these both are combined, that will be the perfect, okay, task. Add a So I have to add a joint here, that is revolute joint. I have to touch here, I guess. So here we can adjust the parameters for the blocks. Double click the revolve joint that you inserted in the previous task to open its dialog box. Okay, expand stages target and click the specific velocity target checkbox. Expand stage target. So where are stage target? This, and check the specific velocity target checkbox. Specified value to 180 degree. 180 degree. So it will go to auto apply. Yep, you can see the proper simulation here. It is sorry, but I can't control my feelings here by just looking at this type of simulations. It's like dream come true for me. I will make a video for this. This is called as engineering, right? Again, let's start. Yeah, so you can see we can look to this type of front. Okay, I can rotate it, and this is the body view, which is so you can see your models in the multi-body explorer in the apps. This is too much fun session for me. Okay, so first model is completed now. Model mechanical system. As you already know, Simscape let you model physical system with behavior for multiple domains without reviewing the equation yourself. Sorry. Sorry for the disruptions. Let's see. First of all, I have to send some notes to my friend. Send that first. Okay. So let's start with the course. Now we have to make a proper kinematics. You can see this is the kinematics model mechanic. I have to learn more about this type of
SimScape
kinematics here.
Multibody brings the power to model, simulate, and visualize 3D mechanical systems right to your fingertips, all within the Simulink environment. To model a mechanical system, simply connect blocks representing bodies, joints, and force elements into a schematic. When you run a simulation, SimScape Multibody handles the equations of motion and rotation matrices behind the scenes for you, so you can focus on tackling the engineering challenges. Now imagine you're building a quadcopter. First, define the bodies that make up the system. Each body is unique, with its own mass, center of gravity, and inertia.
Yes.
And here's the fun part. You get to play fashion designer for your quadcopter. Dress it up in whatever colors are trending this season. Adjust the opacity of individual components. It's like having X-ray vision for mechanical systems.
Yes.
And with the SimScape Multibody Solids library at your disposal, you've got access to fundamental 3D shapes like bricks, spheres, and cylinders to build your mechanical system. You can even define custom 3D solids by extruding or evolving 2D profiles. And if
So
you're
basically it is just like a game development.
familiar with computer-aided design software, you can import entire CAD assembly files directly, saving yourself from the grind of building complex models from scratch. SimScape Multibody automatically extracts necessary information, such as part dimensions and density, to fuel your multibody simulations. Once you've defined the bodies that make up your quadcopter, you proceed to the assembly stage. Each body features a default attachment point, called the reference frame.
Okay.
But if you've got other locations in mind, the rigid transform block has got you covered. This nifty block lets you adjust the relative position and orientation of a frame. When you connect two bodies together at their frames, they become as rigidly bonded as if they got superglued, creating a secure, immovable connection. Now, for parts that require a connection with some mobility, joint blocks let you specify how bodies move relative to each other.
Okay.
Think of it as a mechanical marriage.
Okay. So I have to write that because it is necessary. multi-body. And here also, if to, to make a proper joint, use rigid transformation. Rigid transform, right? To make movable joint, use revolute joint block.
where the rings are replaced by joints, connected yet allowing some movement.
So
For
from
example,
this,
a
I can
revolute joint enables a body to rotate about a single axis. And since this is a Simscape model, your quadcopter assembly can seamlessly tap into electric, hydraulic, or pneumatic energy from existing Simscape networks.
this is the proper mathematics. This is the proper mathematics.
This also gives you the versatility to model additional physical effects like heat transfer and battery depletion over time, enabling you to run high-fidelity, multi-domain simulations of your system. Now that you've assembled and actuated your system, it's showtime. Hit the run button and behold your quadcopter's first flight in Mechanics Explorer. Watch the action as it unfolds, and immortalize the moment by exporting the animation as a video. And there you have it. From concept to virtual flight, you've just witnessed your first multi-body simulation.
And this is how we can make a drone.
Now it's time to try it yourself.
Models. This is a proper new thing for me. Block required by the Simscape multi-body solver configuration. Simscape mechanism configuration and world frame. Multi-body. With this I can make up my proper own satellite. Solver configuration. Mechanism configuration and world frame. Here I can make my own world. It is like making a proper video game. For Z and this is for the mechanical reference. Identify the blocks that you will typically encounter in Simscape multi-body. So now we have to make the sketch robot, and for this, a closer look at the mechanics explorer. You can see the run button there. Okay, and this is the multi-body explorer where I can see the simulations. It is the okay, this will be the part. It is like making a game. That's why everything you learn. Yes, I know about this. Okay, I can zoom the, I can rotate, I can zoom. This is like a CAD. So basically, the time I have invested in game development will be useful for this. Okay, start. I will complete only this exercise, and after that we will. Okay, so this is a coin flipping configuration. So what I have to do here, this is connected, right? This is connected. Now what I have to do here, we have to add the solver needs for simulations, sorry, simscape, mechanic, mechanic configure, and world frame. We have to connect this to this part. Okay, add a solver configuration block, world flame and mount. Connect those three blocks together. Sorry. Connect those blocks together. Okay, I've connected those three blocks together. Then connect the floor reference. The floor reference R to the world frame W port. Yep. But leave the 12 side W coin unconnected now. Next. Familiarize yourself with Mechanical Explorer interface. Rotate the viewpoint to see the reverse side of the coin. So for this I have to go to the modeling, and after that model explorer, no, I have to go to mechanical explorer. If it is there, no, there is no mechanical explorer here. Simulations, there is no mechanical explorer here. If you connected the 12 set coin to the world flame, I connected this to the world side flame and then I click on run, I can see that the coin is between the floor. Yep, you're right about that. This is because the now task, add a rigid transformer here. Rigid transformer, world frame, and follow to the okay. In the block dialog, expand the translation and choose the expand the translation and choose the standard axis method, then specify the offset value to 20 centimeter along plus z axis. Okay, click the update modeling debug button. There is no options here. Click the update model here, update model. Now I can see the coin up front, but there is again one error. We have to solve that. in the rigid transformation, expand the rotation. It is already expanded. Expand the rotation, and again we have to go to the standard axis. Axis is we have to set the angle of 45 degree minus y axis. Next, add a 6 DOF, which is nothing but a 6 degree of freedom. 6 DOF joint J. 6 DOF joint body. Connect its base B to the rigid transformation F. Okay, and this to this. Okay, let's see, will the coin will. Okay, so I think I have to cut this part. Yeah, I have cut that part, and then it's connected here. What about we need? Okay, so I think we will see this later. For today, that's all I can do, because I have to go to the college. That's why. So until then, bye bye. But this is fun, and every fun thing